Good morning, ladies and gentlemen. I hope you have had a good morning. It's nice weather, and I hope you enjoy Helsinki at the best. It's at the best for the moment. Yes, I'm going to give you an insight on 5G, what the expectations are as of today, in general, what the architectural, the use cases might be, go into some of the architecture ideas that there are around, and then go into some special cases here. So first, what is 5G? When LTE or 4G was basically serving one use case, broadband data, mobile data, 5G will serve a number of different use cases. There is a technical evaluation also enabling this. For instance, battery, 10 years on battery would not have been feasible 10 years ago. And that enables new use cases with very low cost sensors that keep doing their specific tasks. Also, the machine-to-machine communication will, although it has been discussed for a while, now finally have the infrastructure and the capability as well as the cost situation to really take off. That will increase the number of devices, of course, 10 to 100. A very careful estimation. I would go farther, but this is the view. Data rate will go up significantly. And we will have fast data whenever we need it. The distribution of data capacity or network capacity will be more intelligent, and you will reserve when you need, but the resources will be used more effectively. Traffic will, of course, increase incredibly, 10,000 times or more. And when we look at the use cases, different use cases, we need ultra reliability. If we have automotive remote controls, logistics happening, we can't just bear with a 10-minute break in the communication. Let's just explore one of the use cases, the autonomous driving, the implication of that. Currently, around 1.5 to 2 million people are killed in car accidents yearly. Around 50-60 million people are injured. To that you can put the material costs. Then we know that the problem or the reason for car accidents to 90% consists of driver mistakes. Okay, can we automate the driver? If we carefully just calculate that the accident rate will go down 50%, you see that there is quite an interesting use case, just only economically. And I wouldn't mind at all to sit in my car and said, drive to the office and read my Hufvudstadsbladet and drink my coffee. Why not? For the 45 minutes that I might need to do. Or, after taiteiden yö, don't think so much that did I now drink 3 or 2 or 1 or 4 glasses of wine. Just say to the car, please take me home and have a nice sleep for a half hour. So, because the use case is so wide, we need definitely to have much more and various requirements in this architecture. One part of this extending battery type is, of course, that you need to have only the session active when it's needed. Network as a service is a new concept. Network slicing is the term there. So we will see new operators or new service providers that get access to the full network because it's virtualized, but just as a part of it, and just needs to or do not need to invest in it upfront, but can pay during the usage team and are using just one tiny part of the network, and this can be tailored for that service provider really special needs. Of course, if the service provider is a logistics company, the needs are different than if it's a company in the healthcare area with monitoring some healthcare activities among the public. Scalability needs to be different. We need to have the we need to be able to scale up to really huge networks, the huge traffic, but we need also to have the cost effectiveness to serve all kinds of traffic. There will be specialized traffics, there will be subnets or sub areas where the traffic amount is not that big, but it has some special activity going on. And then it's through some router connected to the more public network. And this will lead to optimization of the total cost of ownership. Mobility on demand also increases the usage of the network resources. Quality and the user experience. Currently, user experience is, the operators are trying to define the user experience by measuring thousands of different attributes, but they fail to do the real root cause analysis. So here, new ways of doing the analysis is needed, and indications are that machine learning, big data analysis is the path to work for achieving that. And the latency time goes down. The requirement is 1 millisecond, so it's really incredibly low. So what does happen in the network then? So main change is that we will not see separate network elements anymore in separate hardware, but they are in software and they are virtualized inside the cloud, inside the telco cloud. Even the radio part, except the antennas, but the rest are part of the cloud. The communication inside the cloud is based on optic and then based on wireless communication. The access network serves can be like anything, so it's not so that we will have a new 5G activity that somehow conquers out the older ones. The current ones, Wi-Fi, Bluetooth, the different mobile networks will continue to work, but there will be then additionally the new 5G contact. That's partly already evolving inside LTE. Oops. No. Sorry. Then we go to reliability and security part. We see and we know that the growth of cybercrime is continuing. Android is more targeted, not because it's somehow worst or easiest to target, but of course the criminals are cost effective and they think about their business case and they attack where they can gain the most. It's an incredible sum estimation, this 400 billion that is lost to cybercrime. Are we in the right area? The type of different attacks are really are many, and when we move to a new technology, it also means that we will see new attack vectors. Like the cloud, how do we ensure that the cloud really is secure? How can we ensure that the virtual machines inside the cloud are doing the right task and not are captured by some criminals? And the impact of losing control of the cloud is also becoming much bigger than the current impact of losing the control of one network element. So the risk is increasing, the stage is going there. And why are the mobile phones so attractive targets? Of course, it's easy. And there is a lot of information and they are always on. And that's, to be always on, is something that the botnets used for spamming, used for further attacks, denial of service type of attacks do like. It has been discussed during, I think, 10 years now that is the telco network part of the critical infrastructure in the society or not. And it should now finally be very clear that it is part of the critical infrastructure. Also, the impact of attack concerning the capacity in the network is severe. And denial of service type of attacks is not only for the operators, it was recently for Finnish banks, it's for any company serving with actively serving over the businesses, relying on serving the consumer through internet. It's a real threat. What are the challenges in 5G regarding the reliability and security? So the requirement is that there is an excellent network quality and experience of that all time available, and that the trust is there in an end-to-end fashion. The infrastructure must be protected and robust. But the problem is, of course, the broad range of use cases, that the number of devices are connected, and that the technologies is heterogeneous and constantly developing. We need to build in the security from the beginning. We have heard that before. It's not easy to do that because security, the short-term profit of security is not that high. It is the long-term or mid-range cost that should be calculated correctly. Here are some examples of attacks, recent attacks. Controlling your heating and attacking that, very on Keynote. But that one about burglar alarm, that you can get a service for closing via an SMS. I wonder what the people really have been thinking when they gave out that. And the problem with the IoT devices, as Bruce Schneier says, is of course the low cost there. There is not a cost, there is not money enough to afford good security. So what do you need then in those cases need to do is of course to have a excellent network security instead. So, how can we evolve the 5G? What is needed to do that? We need to look at the telco network as part of the critical infrastructure to get it the proper status. We need to understand that the current security level, there might be old IoT devices that are connected, or there might be new low-cost sensors, for instance, that are connected. And we need to have alternative means for mitigating the risks with them. We need to think about the threats beyond 2020. So we have all the current threats are continuing, and we need also to anticipate the new risks that are connected and depending on the new use cases. Take the automotive car system. Of course, there are quite some security consideration there with the control or how the control is done, even if it's distributed. And privacy and user data information needs to be taken into account. And we need to cope with the increased flexibility and dynamic of network functions in distributed cloud environments. What are then the key solutions? One is here, the multi-connectivity is a new concept. Let me open up the picture a little bit. So the gray, this one is the current network with in the 2 gigahertz band with the number here is the spectral efficiency and the number of base stations is the third bulk. And the multi-connectivity means that the user equipment can connect simultaneously to all the different bands, and depending on the need, use that frequency band. And depending on the network situation, the throughput varies. And this gives more than 3 times. This can then give more than 100 mega connection everywhere. It gives extreme mobility, robustness, and ultra reliability, and it gives 3 times more throughput. And with the cloud, we are moving from hardware-based to software-based failure and recovery scenarios. And the reliability will not be depending on the hardware anymore, because it's in the cloud and there are multiple servers, and that's under control. But on the availability of different hosts, of different zones, and the availability of the cloud, and the load of the cloud. And there are new recovery methods, automatic start of virtualized resources. We heard yesterday about the risk for cloud being, or virtual parts of the cloud being used for botnets. And then we have automatic start of the resources. So obviously there is a need also for some kind of security management of the cloud, monitoring the activity. And how do we cope there with the privacy issues? Yeah, and of course, so this picture shows how the current hardware-based networks elements are moved into the cloud. And when we set up the cloud, we need to pay certain attention to the security configuration and the policy management. The security and privacy were built in, but we need, with the configuration, ensure that the built-in functions are operating correctly. And we have new security requirements that must also be addressed in the cloud. And then, when the cloud is up and working, we need dynamically to monitor the activity in it. Network services are created and deleted and scaled dynamically depending on traffic needs in the network. And the security orchestration needs then to follow these changes in the network. And of course, to find malicious activities in the network and prevent those. Mobile Guard is one product that we have launched in Nokia. That is potentially also one tool to use in detection malware that Internet of Things are creating in the network, because it is measuring or monitoring the network traffic. currently several different use cases, and new are added as needed. We are doing we are relying to some extent on the database provided by F-Secure in this product, our partner in security activities. And Mobile Guard has a machine learning capability that is able to detect suspicious patterns. And this is a very interesting path. I believe we can develop much further in listening to different sources in the network and compiling, finding out the malicious. First finding out the suspicious traffic and then going deeper into analyzing it and finding out if it's malicious or not. It's a big problem when there is a new type of traffic coming out for the first time to decide if it's malicious or not. And it might be that we need to change our attitude on zero tolerance towards false positive here. We'll see. For Nokia is cooperation the key that we are choosing. That's why we are here today. We do that from this development and security perspective in 3 different ways. We do research together with vendors, together with academia, and together with industry partners. And here are 4 different projects, 2 in Finland, CLOSE and CyberTrust, where we are active, and then European level 5G Norma and SASE. We are also very active in standardization, where we together with other vendors and operators jointly develop the standards. Standards are needed to ensure basic security. It's also, of course, needed to ensure interoperability. Somebody has claimed that the standardization is very expensive. It's very true. What is the business case of standardization for market leaders or big companies? And in the operation, we are also cooperating with our customers, with our authorities, and share threat information in order to improve the overall security. So what are the security and reliability parts in the 5G? When we have the multi-connectivity, when we have the programmability and automation, we have the data analytics capability, and all the network elements, the functions are basically in software inside the cloud and virtualized. We need new concepts, functions, and interfaces. For instance, current research topics there, what we are developing are in the area of how to securely boot a cloud, how to mitigate denial of service type attack in the cloud. the adaptivity of security controls means that we need to learn, we need to have intelligence, we need to learn about different types of traffics and situations and incidents, and adapt the security controls accordingly. And there will be a lot of new use cases with specific security requirements to cover device-to-device, Internet of Things, communication to anything. Okay. So the security needs to be built in for the next, for 5G. We have the use cases of low latency services. We have innovative new use cases. We have edge computing in a new way, so device to device, communicating directly, not going via the base station or yeah. We have virtual network with local services, the network slicing, or ad hoc virtual subnets. We have a new, we are reaching the programmable world Nokia has been visioning through the, for instance, through the intelligent devices. And we need to have integrated control with traffic steering and service chaining. And all this is in the cloud, cloudified, virtualized, and software-driven. So built-in security right away from the start. We do have a process for security, and we do our best to build in the security from the very beginning. For already 10 years, we have had a design for security process inside Nokia, starting with threat and risk analysis for the product, creating a security architecture and creating the security requirements. Security requirements are to some extent common for the telco network, but also they can also and will in the future increasingly be product specific or service specific. Then the software is created with good secure coding, knowledge, and honoring the coding principles there. The software is tested and security is tested in them. And finally, when the product is ready to be launched, the security is audited by external company to ensure that the requirements previously agreed are fulfilled. But perhaps not, this is perhaps not the case always. There was an interesting situation in US Virginia about machine-to-machine communication, voting machines, built in 2003 based on Windows XP. The software was not patched since 2005. When analyzed, they were wirelessly connected. When monitoring, listening to the traffic, it took 2 minutes to break the password. The password was hard-coded at ABCDE. After that, you could attack the, and there was system level, root level accounts on each of the voting machines, and you could attack them. Password there was admin. You could then connect with a phone to the system where they were communicating between the voting machines and collecting the voting results. There was the functionality to change, update the voting results. No logs were provided. This was in work for 12 or over 10 years, and over 1,000 of elections in Virginia was conducted with this system. So, Nokia are the future, ready to bring our vision to reality. Then I have still, what's time? What's the time? I have still, 6 minutes. Very good. Here are some key milestones on how we see the road towards 5G. So we have had already the first showcases for in Mobile World Congress. We have quite some cooperation with Docomo in Japan, and we have also communication or research activities together with China Mobile and their research institute. Now 5G PPP projects are started, and the standardization in 3GPP is started this year. Next year we will see 5G demos, some specific activities hopefully ready in 3GPP in the standardization. In 2017 we will see single RAN of 5G system, for 5G system. 3GPP should be in full progress. In 2018, pre-standardized trials will be launched. After that, in 2019, the pre-commercial trials, and in 2020, commercial network opened. Docomo is estimated to be the first one here. So not too far away, and we'll have a dramatic change on the telco network compared on what we have today. Thank you. Any questions?
So we can take 2-3 questions. While you think about it, let me ask one. Do you see that the operators are willing and prepared in 5G to take some kind of responsibility for the security of the end user owned devices? Sort of this might be a stumbling block. It's a question of responsibility, and what does that mean?
Yeah, what would be the driver for them to change it? Legislation would be one driver. Have we seen the sign of that currently? Not yet, not really. And this is, of course, also somehow philosophical question: to what extent is it right to outsource the security to the operator? To what extent must the end user still bear their responsibility?
If the end users are allowed to put into network devices that have no means of upgrading their software, and some vendors can sell this stuff to the consumer markets, and then you need these kinds of mobile cards, which mean that somebody who owns a network device takes responsibility for the security of the end user devices. This is the dilemma. If there are 100 million TVs that are vulnerable and can be used as bots, what can we do if nobody takes responsibility? So more questions.
Thank you very much for your presentation. This is Hai Guang from Huawei. I have two questions. Firstly is in your slides, page 12, you mentioned about this E2E end-to-end management. May I know that in the 5G, are we going to provide end-to-end security service for the users?
So end-to-end security for the
end-to-end, for example, 2UE. Are we going to provide end-to-end security?
M2M.
End-to-end.
End.
E2E security.
End-to-end security, yes.
Yes.
Yes. Because what is the point of having security just somewhere in the network if it's then broken in the next point? So of course it must be end-to-end. Yes.
Okay, thank you. My second question is, you know, in the 4G networks, we have lots of Wi-Fi APs deployed by the operators to offload the data. So, however, there could be quite a number of Wi-Fi security issues. Yeah, are we going to? I mean, it is foreseen that in the 5G, the Wi-Fi will continue playing an important role for the operators. So, have you considered this Wi-Fi security in your 5G framework, security framework?
So the question is, do I understand the question right? So you have basically insecure Wi-Fi networks, and the risk is then when they are connected to 5G that you upload also malware through that channel. Yes, that is of course a risk. And the mitigation part is then to have this more intelligent network security capability there, observing this activity and then, if needed, block it.
Okay, thank you very much.
Thank you.
The gentleman asked about the end-to-end security, and you said, yes, it is going to be taken care of by 5G. And if you remember, recently there are a lot of hackings which is happening into the conversations between the end-to-end client. And one of the issues they have identified is with the weakness within the SS7 signals. SS7 signals.
Okay.
That's exactly where the telco providers, they need to really put a lot of efforts to fix that thing. Now, can you exactly tell what end-to-end security aspects you are considering in protecting the end-to-end devices?
First, yes, SS7 is really a big problem, and we have spent quite some big effort in analyzing it, finding the mitigation mechanism, communication that to both the operators and the authorities. Yep, there is not a short answer to say how can we solve end-to-end security, especially for the end devices. There is not a silver bullet. We need to do multiple things. We need to address the vendors that are providing devices. We need to have good network security, monitoring the traffic. We need to have good agreement that yes, malicious traffic, it's allowed both to block it, and malicious traffic is not, it is not secured or it is not shielded by privacy legislation because it's malicious traffic. Thank you.
Thank you.